Hello everyone, welcome back. In this video, we will discuss about the classification of Lewis acid and Lewis base. In one of our earlier video, we have seen a brief introduction on the Lewis acid and different types of Lewis acid and base concept. According to the Lewis acid and base concept, acid is an electron pair acceptor. It behaves as an electrophile. Base is an electron pair donor, behaves as a nucleophile. So when acceptor and donor react, it gives a donor-acceptor complex. So example like you have a BF3 boron trifluoride on reaction with ammonia. You get F3PNH3. Since you know that boron is a atomic number 5, it is in group number 13 and valence electron is 3. So it make a 3 bond in, but this boron behave as a empty orbitals or vacant orbital which has a capacity to accept electron in order to maintain the octet form of configuration. So it has ability to accept a proton or ability to accept a pair of electron. So it behaves as a Lewis base, Lewis acid. Whereas ammonia, the nitrogen has a valence electron 5, 2 are free, it is a lone pair. Due to lone pair, it behaves as a electron donor. So when the chemical reaction takes place, due to boron trifluoride, in boron trifluoride, the boron has a Lewis acid capacity ability because it has a vacancy orbital, electron deficient, which has a ability to accept a pair of electron in order to maintain the octet configuration. So this lone pair will go and attack and form a bonding. So this is a donor. It behaves as a base, Lewis base. Similarly, if you react HCl or any acid, hydrogen will release. It can be from the water, it can be from any of the hydrogen proton releasing compound, ammonia. This lone pair will go and attack and you get ammonium ion. So this is the concept of Lewis acid and base. Classification of Lewis acid. Lewis acid are classified on the following categories. Category number 1 is cation act as a Lewis acid. Cations have a properties to show about the acid properties. There's some smaller cation like smaller cations such as hydrogen, lithium, beryllium 2+, etc. They have an ability to accept a pair of electron. Ability to accept an electron pair. So due to that, it behaves as a strong Lewis acid. Whereas some cation like larger cation, if you see in the periodic table, group number 1, this group number 1 is called alkaline, group number 2 is alkali earth metal. So the group number 1 and 2, most of the group number 1 and 2 elements They are alkali and alkaline earth metal. That is group number 1 and group number 2. They have a lesser tendency to accept electron. Lesser tendency to accept pair of electron due to their large size. So they behave as a weak Lewis acid. So the properties like cations act as a Lewis acid. The smaller cations, they have a higher ability to accept a pair of electron. Due to that, they have strong valence. Due to that, they are called strong Lewis acid. Whereas the larger cation, it can be seen mostly in the alkali and alkali earth metals. They have a lesser tendency to accept a pair of electron because they are strong reactivity. So they always occur in a combined state. So most of the alkali and alkali earth metals, they have a tendency to accept pair of electron, but they act as a weak acid because of their large cation size. So some example in the deep lock elements like Fe2 plus and Fe3 plus. So this iron 3 plus and 2 plus, this Fe3 plus will be the weaker as compared to Fe2 plus. Fe2 plus is smaller cation. It behaves as a strong acid. It behaves as a weak acid. So the larger the size of cation, the weaker the acidity character. Some example like you have SN4 plus. It is weaker than Fe3 plus. Or you have some another example like you have Al plus 2 Al plus 3. So this Fe3, this aluminum plus 2 ion and plus 3, this is Al plus 2 or 2 plus will be much stronger as compared to this. So the cation also acts as a Lewis acid. Another type of Lewis acid, the electron deficient or electron orbitals also behave as a Lewis acid. So some electron deficient compound which have a central atom, example like you have BF3, ALF3, GABR3, GeCl2. All these compounds are electron deficient and they have the ability to accept ability to accept electron pair to complete their octet. So they behave as a Lewis acid. Even though their bond is balanced, they have the valence orbitals in their molecular orbital diagram. So they have the ability to accept a pair of electrons and in order to maintain octet. So they behave as a Lewis acid. Example, this BF3 when react with F minus, it behaves as this is a Lewis acid and Lewis base. So it bond will react and you get the F3, F4, PF4. Some example like SnCl4 is also it also behave as a, it has electron deficient compound. Lewis, it behave as a Lewis acid. So when react with two molecules of Cl minus, you get the SnCl6 concentration of 2 minus because 2 chlorine has been added. Similarly, if you react with silicon trichloride or trifluoride, when react with two molecules of fluorine, you get Si tetrafluoride, hexafluoride, 2 minus. So in this way, the electron deficient compound also behave as a Lewis acid. Classification of Lewis base. As we have discussed, base behave as a nucleophile which have the capacity to donate a pair of electron. It has nucleophile properties, it can donate a pair of electron. So all anion has a negative charge. Like oxide, you have anion like oxide, O2 minus, you have OH minus, hydroxide, you have halide, it can be fluorine, chlorine, bromine, etc. All the halide, fluorine, chlorine, bromine, etc., it has a negative charge. Oxide, hydroxide, NH2 minus, etc. They have the Lewis base because it behaves as a nucleophile and it can donate a pair of electron to the Lewis acid. The larger the size, larger the charge density on the anion, the stronger will be the base. So larger the charge density, greater will be the base. The lesser the charge density, the lesser will be the basicity. So this is the classifications of Lewis acid and Lewis base. So that's all for today's in this period and in this video. If you have any question, you can always ask. Thank you for watching.